Hello everyone, welcome back to the channel. In today's video, we will see how to estimate the instability index in Excel. Before getting into the video, we need to know what is meant by instability index. So, instability index in general refers to the year to year fluctuations in any particular variable. Say for example, we have a time series data and we have a growth over a period of time. So instability refers to year fluctuation, how much it has been fluctuated over a period of time. So in order to measure this instability, in general the coefficient of variation is used to measure it. But very often what happens is that if we use a coefficient of variation, sometimes it overestimates the instability because they do not remove the trend component. Because in all the time series data we will be knowing that there are different time series components, either trend or cyclical or seasonal or irregular pattern appears in the data. So the CV sometimes overestimates the instability because of this trend component. So in order to overcome this issue, researchers commonly use the another instability indexes, that is CDVI. So the CDVI is nothing but Cuddy Della Valle Instability Index. So this index, CDVI index, includes the time trend, and based on the time trend, and it nullifies the time trend, and it estimates the instability index. So in order to calculate this CDVI, let's get into our Excel data set. So this is our data set. Here I have different states and their area for a particular crop. So in this, here I have taken the time series data starting from 1977 to 24 to 25, and state-wise area for certain states. So now first thing we need to do is that we need to calculate the forecasted values for each year and for each state. So in order to calculate the forecasted values, I'll simply use the formula. So here I'll take this value minus intercept. So intercept, here I'll be taking the values starting from C3 to C47, and I'll be taking the time trend, that is our x is the time. So I'll take from, I've just numbered the years to represent the time. So followed by that slope. So in slope I'll use y value. So again I'll select our uh, state area, and followed by that our time trend. Okay, so followed by that I'll slope, followed by that multiplied by the time trend, which is nothing but the basic linear regression equation. So I'm just trying to calculate it directly, that's it. So this is how we will be calculating the forecasted values for each. So I'll just fix the range so that it won't change. So we got all the values for Tamil Nadu. Similar way, what we need to do is that we need to calculate for rest of the states. So here I'll just take one state for a particular thing, and next step is we need to calculate the coefficient of variation. So in order to before getting into that coefficient of variation, I also need to share with you the the formula for CDVI. So for CDVI, we use CV multiplied by square root of 1 minus adjacent r square. So this is the formula for estimating CDVI. So that's what I'm trying to do now. So here I've calculated the forecasted values for each time, and followed by that, now we will be calculating the CV. So for a CV, I'll take two periods. Say for example, I'll be taking before and after. So what I'm going to do is I'm going to compare the instability from 1977 to 2000 and compared with 2000 to 2010 or something like that. So I'm going to separate my data set into two. Say for example, pre-adoption and post-adoption, before and adoption and after adoption. So how the instability is varying. So that's what I'm trying to do now. So what I will do is I'll find the standard deviation, population standard deviation. So for population standard deviation, I'll be taking the values. Say for example, I will take up to 2000. So from 1977 to 2000 I will take. So standard deviation divided by the mean, so that is the coefficient of variations. Okay, so for mean, I will be taking the original values, that is the actual values. So for this I'll take the actual values, and finally multiply by 100. So now I got the CV for before adoption period. So similar way I need to calculate the after adoption period's CV. So similar way I'll calculate the CV for, say for example, from 2001 to 2020. I'll take by the mean, that is the average. So multiplied by 100. So now we got the before and after CVs for our data. So next thing we need to do is that we need to find the adjacent r square. So in order to find it, I have the formula square root of 1 minus r square. So 1 minus r square, my x and y variables. So in my case, the x and y variables are comma. So now I got the 1 minus adjacent r square, and now we can find the CDVI values. So the CDVI values before and after. So simply we will be multiplying the CV with our values, and we'll be getting the CDVI. So now you can see that we got the instability index of 23 before adoption and 28 for after adoption. Say for example, so this is our before adoption, and this is for our after adoption CDVI. So the CDVI we can easily interpret using the it is an index, so we can easily interpret, because if the values is very higher, we can say it has the higher instability. If the values are very less, we can say the lesser instability. So while we are comparing between two time periods, we can compare the CDVI values, and we can easily interpret the results. So this is the easy and simple way of estimating the CDVI. I hope you have learned how to estimate CDVI. Let's meet in the next video. Thank you.